So a job resource is a single task which terminates or completes. So it could be one task which runs only one time, or it could be a repeatable task which runs after or completes. So it could be one task which runs only one time, or it could be a repeatable task which runs after certain intervals. So generally when you have a pod, if something happens to the pod, a container inside the pod, the pod gets restarted. But here what we want is when the job inside the container is finished, then it should not restart. Nothing should happen to the pod. And so we want that. But when the node gets failed, the pods on that node should be rescheduled to another node by the job resource. And that's what job resource does. So if you have a job running on some pod and the node has failed, it will, as normal Kubernetes process, it will start the same pod which has a job resource on the other node. Process failures, if you have to identify the job which is running inside your pod, if that is successful or not, that is identified by the return code of that job. If return code, generally you see, right, -1 or something is considered as failure. Same is the case here. You can configure the job to restart after the, in case of failure, it can restart the container because failure might have happened because of some temporary issue with the container. Or you can configure to not restart the container, because even if you restart, nothing is going to happen, job might still fail. So these are the configurations which you can do. So what I have done for this, just an experimentation, I created a separate code repo, and that code repo is, geocoding, because I wanted to do some one-time task. So there is something which does something and then finishes it. So it's a Maven application, Maven Java application. It has a main method. So you can, jar is built by Maven with many class defined in form.xml. So in form.xml has all the setup and everything. So once you do Maven clean install, it will build a jar which is, which is runnable. So it knows which main method is. So I'll tell you, what. So in this place, this is the, the code. So only one class is there, reverse geocoder. So at any time in your, if you ever work with the geocoding or geocoder, geocoding is basically, getting the latitude and longitude based upon the address. Reverse geocoding is you pass the latitude and longitude. This is the latitude and longitude I am passing. You can get the address. So this is the external API I'm invoking, API position stack, whatever, reverse geocoding. And this my key, this is a confidential key. If you want to access, maybe you can create your own or whatever. And so this is the API which I'm invoking. And then I get the response. And I think somewhere I'm just printing the response. I'm not doing anything. I'm just saying system.out.println and get the response and print it. This is the main method from the main method. So main method call this reverse geocoder. Only one thing is, because I want to simulate the error scenarios also. I want this, what I want to show what happens to the job, Kubernetes job, when error happens, when the job runs into error. So create this error, to create these error scenarios, I sort of, designed this, a Boolean flag you can pass in the constructor of this job. And if Boolean flag is true, then it considers the wrong data. And then if it is wrong data, if the flag is true, it just throw an exception. It's wrong data, throwing exception or something, right? So something like this I do. There is one more thing somewhere I had put, if you pass more than one argument also, then also it fails. We'll see that. So right now, this is how the job is. And now going back to the slides. Okay. Now let's see so I have created a Docker file out of this. So this is, I use this image and, work directory, whatever. This is a normal Docker file. From this Docker file, I created I run this Docker file. I created an image. If you are using Minikube and you create, this is how you create the image. Docker build -t, then geocoder. This is the name of the image, geocoder. It should be GEO. So this is the name of the image, and this is the image I created. And once you have this image, then if you are using Minikube, then you have to specifically load that image. If you are using Docker desktop, then you don't have to do this step. But in the Minikube, we have to do, because Minikube does not recognize images we just created using Docker automatically. So you load this image which you created using Docker in Minikube so that you can use that. Now, as I said, there are two types of jobs. A one-time job which runs once and finishes and then never runs again. Second is cron job, which needs to run at periodic intervals. So both are supported by Kubernetes job resource. You can restart if the job has failed. You can restart the job, or you can configure it to not restart also. And we'll see one example of that. So this is one YAML file of a job. So what I do is, this is the batch v1 version, API version for a job, and kind is job. This is the name I'm giving. Then this is a template. This name and this name should match, because this is type job. It will create a code also for this job, so they should match. Actually, no, this is just a name and this is a label. That's fine. You have to create a spec, and there it's a normal pod template, right? Restart policy on failure, containers. This is the name of the container. I'm giving the same name as the image name. Image pull policy is never. I'm telling not to go to Docker repository because my image is already on my local. And this is what I pass. Java -jar, and all of this, right? This is the because in the Docker file I had already I created a Docker file also, and then I'm just running this Java -jar and creating this. So just checking something. Yeah, so everything is in the source folder. So you compile it, and then I already have the jar file created. So in the Docker file, jar file is jar file is already uploaded, and then you can run this Java -jar, and this is a command. When the code starts, container will start with this process. And now this I already explained you. API version, label, create code, and job object should have same label. So spec template metadata label, spec template metadata label. This is the name, and create code and job object should have this label. So I think the label needs to be same. This is a geocoder app, and this label I have not defined. I don't think this should be same. The image, restart policy, and then you create. So let's do one thing. I will create this job right now, and these YAML files are inside this project itself. Inside this project itself. So all the job YAMLs are here. So what I'm going to create is I'm going to go to that project. So I'm inside that project. So I create, this is the this is a job. This is the YAML file. So whatever I explained, I have given that here. We'll come to this back of limit 2 later in the session. So let me create this file, create this job. F. This is the name of YAML. So now if you see kubectl get job. So one job, right? Now you see, let me show you get code also, so that there's something which I want to explain. Now if you see, right, the job, it is supposed to have one completion, and that completion is over. So it's 1 out of 1 completion is over. It's one-time job. In the pod, you will see, it's 0 out of 1 is ready, but the status is completed. Status is not failure like you see, when you have a problem in starting your pod or container. Here, status is completed means, of course, this pod is created by this job only, and it was supposed to run some process, some code. It did finish, and it's completed. So now it's no longer running, right? And the reason it stays here, ideally, you could very well delete this job after it is completed. But if you delete this pod after it's completed, but they don't delete the pod after the job is completed, in case you want to see the logs of this pod, whatever has happened. That's why it's not deleted, although it is completed and it's not running anymore, right? So now let's see that. This I explained. Now, what I do in my code, if you go and see the code, what I do in that code is I showed you, uh, I run the, I print the geocode address. So I pass this latitude and longitude, and whatever response I get, I print that. So if I print that, then let's see, it should be available somewhere. So for that, let me go back here and let me put in the slideshow. So I can see the kubectl logs. So first you can see the, okay, you can see one more thing I wanted to show you was this. We were discussing about the labels in the job and the pod. So let's see both labels. So you have this job, I can say show labels. And I have this pod, show labels. So both are going to have the same labels, app geocoder job and app geocoder job. So that's how you can always, describe the, job also. But this way, this is a job, geocoder hyphen job, and this is a type job, because no, sorry, this is type job because I saw the job. It has the same label, and this is type pod, which has the same label, right? So because it got started by the job, so it ended up giving the same label to pod and the job also. Now it has run once because it's completed, and you see 1 out of 1 completion is done. So I want to see the logs also. So kubectl get logs pod. Sorry, mistake, kubectl logs. So this is the, this is some other spam retreat Bangalore, and I just found out the latitude longitude of some property and I was seeing, and they showed the map. I copied the latitude longitude of that and used that the same thing. It's some property in other spam street in Bangalore or something in Belanduru. It's near Belanduru, so you can see all of that. This is the one. It's in India, and all those things. Somewhere it must be in Bangalore also. This is the name and all those things. So you can see that. Here it's in region called Karnataka. County is Bangalore, which is city. Locality is Bangalore. Neighborhood is this, whatever. So this is the result which is given by the service, and I just logged it. So now what we are doing is, if the job fails, right? So what happens? So I have this, we'll see. I have this YAML file, job one-time failure. So we have the restart policy. I think let's see this YAML file, job one-time failure. Get job one-time failure. So you have restart policy of never, and I'll tell you what this never is. Never, we misunderstand that it will not restart if it fails. It's not that. And this back off limit is true, and I will explain what that limit is. So before I run this, let me delete the existing job which I have. So kubectl get jobs, and if I see get ports also, if I delete the job, pod will automatically go away. So kubectl delete job, and it got deleted. Now if you see the job, there's nothing. If I see the pod, there's nothing, because the pod was started by the job itself. Now let's run this. kubectl create SMS. So this pod got job and pod both would have gotten created now. So if I see this get pod, it's running into error, and you see it's starting. It keeps starting. If I see this, after some time it keeps starting. But let's see the job also. So job is not even completed, and why it's running into error? So somewhere in my code I have the logic that if you pass an argument, then the job will run into an error. Okay, that's how the code is designed. Now it's running, and it only thing I have said is let's see the code. It will keep starting. And you will see after some time it keeps starting it forever. While it's doing that, let's see that restart policy is on failure. There are, I think I have changed. I had in the, when I copied paste this, I had it on failure, but now you had never. So we'll see both of the same. It will restart the job on the same port. 6 is limit by default for how many times restart will happen. So what we are going to do is I change it to never. Now let me change it back to restart policy on failure and then see what happens, right? So, but in the meantime, let's see. It started only 3 times. Okay. CTL get jobs. So job is still there. I'm just checking this. CTL delete job. So job got deleted. Pod will also go away now. Job also is gone. Right. So now let me modify this this file. What is that? Let me copy paste the file name. VIM. Then job one time failure. Job one time failure. And what was the restart policy on failure? Just validating it on failure only. Yes. On failure. So let me restart this. Control R. Sorry, Control C. Control R. Create. Got created. CTL get jobs. Job is there. Get pods. So pod is there. So now we'll see what happens. It will restart. You will see the number of restarts increasing here. Right? That's what is going to happen. Oh, pod went away. What happened? Sorry. Job is there. Strange. So generally, we have to check why it's not restarting. But when you have the on failure, it will restart the job on the same pod. So I'm wondering whether starting a new pod itself. CTL describe job, and where is my job? Not pod. This is my job. So job has reached specified backoff limit. Okay. So generally the backoff limit is 6. Either it is less or we did not see suddenly it reached out the backoff limit, and then it's deleted the port. So it created the port and deleted the port. Something like this had happened. Immediately it found these are not in right order. These are happened only at the same time. So first it should have come. Job has reached the specified backoff limit, and it is 2 times in 44 seconds. For me, I have changed it to if 2 times it fails, then just consider as failure, and then it leads a job. But the thing is, it happens on the same port. That's the advantage of on failure. Now you saw I had given a never here. So never means it will not start on the same port. It will keep starting on the different ports, and it will make all the ports available. And we'll see that also. So this is what I had done, and I was seeing this error. Initially restart was 0, then restart became 1, and so that's how it was happening. Now okay, so now we'll change the restart. This is what I had done. So I had just done restart policy was never. Now this is what was happening. It just kept creating the ports after ports to keep retrying. You see some port got created 6 minutes back also. So here never will restart the job on different port. It has no limit by default for how many times restart will happen on different port. See here, you knew that at least by default 6 times, and somehow I changed it to 2 times for me, that on the same port on failure, when it happens 6 times, then just consider the job as a failed and delete the port and everything. It will still keep the job though, but it will delete the port. But when you have never, it will just, never ends. That's what never means. It just keeps doing it. Now we want to control it, right? And, So basically, oh, I know why it's happened. Sorry, why it happened 2 times. I know. So let me show you the file. This is a good thing. We will test that also right now. So LT, so one time success. Yes, it's a back of limit. So so I had changed that back of limit. So VIM, oh, VIM. So I had given this back of limit of 2. So let me, if I remove this, we'll test it out right away. We'll remove this and let's delete the kubectl get jobs. So let's delete that job. Kubectl delete job. Now let's run this again, and this had on never. I changed it to no on failure. I should have created different YAMLs for this, but bear with me. On failure. So if I do this on failure, now kubectl create SMS and it got created. Now let's see, get the ports. Get port. It will just keep restarting. I think, I don't know how long it waits, but it will keep starting, and after 6 times it will say it's done. Okay, yeah. So we saw it restarted around 2 times and then backed off. I remove the back of limit. Oh, it says completed. Sorry, my mistake. I should not have changed this. This is a success file. I changed the success file. I should have changed the failed file. So let me delete the pod again. Delete pod. Deleted the pod. Now let me change this one. It had back of limit, and that's where it will start. Because here I'm passing a parameter, extra parameter, which makes my job fail. So now let's see that. So kubectl create -f on this file. So let's get the ports. So restart happened once, restart happened after some time again, restart will happen. Keep doing it. We'll check it later. Let's move on with the other parts. So you will see restart keep increasing, and after 6 times it will just delete the port itself. And we can see the described job. It will tell you why we deleted that. So restart second time has happened incidentally after some 20 seconds or so. It does that. So we'll see 6 times. But let's move on. So for restart policy never, these many times pod will start on different nodes. I mean, whatever nodes is available to, because on never the new pods get created, and whatever scheduler decides wherever whichever nodes have the pod, it will get restarted. So there's no guarantee that the pod will be started on the same node. So that now we discuss the difference between on failure and specify. So to control the number of restarts, we can specify the back of limit. So it works for never also. With never also we can specify the back of limit. Now let's see, and I want to move on to the different one. Still 3. So let it complete to 6. And in the meantime, let's see describe the job. So it still has that it's successfully created pod, and the pod is still running because it has on failure. So it will restart for the 6 times, and then so I'm just deleting that. I want to discuss the other things also, but you get the idea. So now jobs can be configured to run more than one pod instance. Those instances can run parallelly, or you can run sequentially also, and we'll see example of those. It is done by setting the completions and the parallelism properties in the job spec. And this is an example. So here I want to run sequentially. So I have this job and the name of the job is this. And in the completions, I want to see 5. And rest of the everything is same. So now here I am changing it to just 5. And I am not in the subsequent, when you want to run parallelly, you can give parallelism flag. But here I am not giving this parallelism flag. So which means by default, it will start one after another, and we'll see that also. Let's see where it has reached. It's still 4. Okay. So in the meantime, let's look at this file. So job one time multiple instances of file VIM job one time multiple instances. I think I renamed it to sequentially. SC sequentially, and I might rename the job also to sequentially, so that I can identify sequentially. Now I am running this 5 instances of sequentially, and all will do the same thing. Right? I'm not passing any extra parameters so that my job won't fail, and I can see the logs all 5 times. I should see the address based on the latitude and longitude which we have. So now let's do this. kubectl create -f. So I've got created kubectl get jobs. Sorry, what was it? Get jobs. So 2 out of 5 are running. If I do it again, 4 out of 5, but I can see the ports also. So one port was anyway, so these are the ports, these are the ports started by this job sequence object, right? So now this this was the one which was running previously, right? So this will go off after a certain time when it started 6. So so now and these are all completed because these are successful jobs. These are completed and no longer running. Now if I see the logs of any of these, kubectl logs code, I will see the address, and I can pick up any other. Let's say the last one also I pick up. Control C kubectl logs port. So same thing. So all ports are doing the same thing. Let's see. These are all completed, and these are all still running, so that I can see the log. The previous one from the previous one is still somehow not started 6 times. So we'll just wait for that. Now what I'm going to do is I'm going to delete the sequential job. kubectl get jobs. kubectl delete job. And this sequential. So 5 out of 5 are running, and the other one is running to error. So it's still 0 out of sorry. This one. And got deleted. So I won't see that anymore, and I see the ports. I won't see that. Still starting 5 times, so still waiting. Okay. Just give me 1 second. Okay. So this is how you run sequentially, and so I have given the 5 instances that we run 5. First, when the way it runs is one port it creates. After first port is created, it finishes the job which I told it to do. Once it is finished, then it will start the second one. And second, the port will not be deleted. Port will still be there, but the job which I had told it to run inside the YAML file, it will run that, and it will mark as completed. Then third port will start, and then fourth will start, and fifth port will start, like this, one after another. If there's any port failure, it will trigger that job creating, it will trigger the job by creating a new port and submit the job there. If I run this parallelly, so it will see here I have given, it will in total run 5 jobs, and 3 ports will get created and done parallelly. And once any of these get over, then fourth gets picked up, then another is over, then fifth gets picked up. So that's how it's run. So I'll show you that also, but let's see, complete this slide first. After container of, so these 3 ports get created and run parallelly. After container of any port finishes, the next port is created. Port failures will trigger job creating a new port. So this is a YAML file, and I had run this YAML file earlier when I created this slide. And you could see that at one time, and you got the ports after it got created, you'll see at one time 3 are running, and after some time 2 are over, and then another 2 got started, so total 5 are running. So you will not see more than 3 started at the same time. The container creating or running, those status together won't cross more than 3. So this is how it is. So let's run that now also. Let's see what happened to this. So that is gone. It completed 6 times. So back of limit reached and that is gone. So now let's see get jobs. Let me delete that job also. Ctl delete job. Now there is no job and there is no pod. So what I'm going to do is kubectl create -f and job. Still, these are not cron job. These are still one-time jobs. Job one time, multiple instances parallelly. Let's see this first. Let me copy this. Control C. Let's see it's the same file which I'm showing you in the slide. Okay, so completions 5, total 5, 3 parallel can run at the same time, and this is the command I wanted to run. So Control V. Sorry, mistake. What did I do? Control C. kubectl create -f. So job got created. So kubectl get jobs. I see these 3 are running at the same time because this is what I have to hold. So if you see the code, it might have completed all by the time we run this command, it had completed all the jobs. But at 3 at same time it ran. So you can see the output of this. I will see output from the one kubectl logs code. K KUBE, and you can see same command, right? So this is how it runs parallelly. So let's go through this. You can change the number of parallelism. So I have given 3. So let's go through this first. Scaling job can change parallelism and job is running. It's similar like if you've seen in replica set, we have increase the number of replica in the replica set also. So you can use kubectl command, scale command. So kubectl scale job and -fn replica 3. So cron tab, as you all know, right? You have worked in the some time or other. You might have used cron text. So you can run the job either at defined intervals or one time in future. And here in the previous YAMLs, we were getting job of type the resource type as job. Here the resource type will be cron job, and it is the cron tab format. So at configured time, what happens when it is supposed to run when Kubernetes is supposed to run that job? A job resource as per the job template will be created. One or more replica created and job started as per the job template. Okay. So there is something called starting deadline second. If the job here I have given, for example, 15 in the spec I will show you in the YAML file also. If the job does not start after 15 seconds, after the scheduled time, then job will not run and it will be marked as failure. So this is how we run. Actually, I have not given that here. It should have, you see spec and you see schedule. So after spec, after schedule, you could do the starting deadline seconds also. But let's go through this cron tab. Now you see the difference. The kind is cron tab. The metadata name is, the G-coder job. So name of the job, it will be appearing in the kubectl get jobs. This is the spec and this is the schedule because it's cron job. So I can give the schedule. And if you don't know the cron schedule, this is how it works. So you have this, the first thing here is the minutes between 0 to 59. Second thing is hours. Third thing is day of month, 1 to 31. And then day of the year. And then day of the week, right? And 0 to 7. So 0 and 7 both are Sundays because 0 to 7 is total 8. So 0 and 7 both are considered Sundays. So here I'm given this, minute, which is */2, which means it runs every 2 minutes of every hour, every day of the week, every month. That's what it means. And same, I'm using the geocoder image and rest of the things are same. And we already discussed the restart policy. So let's see the cron job here. So cat ls, don't remember. I keep changing the file names. So I want to see which file is as a cron job. So cat job cron. So this is the same file which I showed you. So what I'm going to do is, let's see any existing code running or job running. There's a job. Let me delete that jobs. kubectl delete job. Sorry, job. Job got deleted. I will not have any job, and I will not have any code also, because all codes were for that job. Now what I'm going to do is, I'm going to create this create a job from this symbol, cron symbol. So kubectl create SMS. So this job got created. So let's see the now let's go through this. Earlier I was seeing the jobs. Now I have to see cron jobs. So let's see that cron jobs. So I am seeing this cron. So it's still running and it's not suspended. It will run after each 2 minutes, and let's see the pod also. If there's any pod, it has, because the 2 minutes are not over. So there's no pod. Once 2 minutes it's about to start, it will start a pod and run on that pod. So let's wait. Get pod. It got started now, and it completed also, by the way. So within 29 seconds it got started. Just before 29 seconds before it got started, and it finished within 29 seconds itself. So after 2 minutes we'll start again, and you will see the difference. Let it run. We'll move on to the other one in the meantime. I think that is all for the jobs. So I'll stop, and you can see the Kubernetes documentation of cron jobs here. I did not put Kubernetes documentation for job. I think that also will be similar /jobs or something. So that's about jobs. There is one thing for replica, changing at runtime, that I will tell you in the next session. But we discuss jobs, single completed jobs, what happens on failure, and restart policy on failure and never, and the cron jobs. So these are the topics we discussed.